In 2020, Elon Musk confidentially stated that his company, SpaceX, would land the first human on Mars by 2026. Now, in 2025, with just 1 year remaining before his ambitious deadline, we must ask, is this goal still realistic? From what we can observe, Musk has not yet succeeded in making this vision a reality, and the possibility of seeing a human on Mars anytime soon seems, to put it mildly, unlikely. Meanwhile, NASA appears to be in no rush either. Instead of heading directly to Mars, they are currently focused on returning to the Moon, though even those missions have faced repeated delays. Meanwhile, NASA doesn't appear to be in a rush. They're only now focusing on missions to the Moon again, and even those keep getting postponed. So what went wrong? Why is it so hard to travel to Mars? If we made it to the Moon more than 50 years ago, why haven't we set foot on Mars yet? How exactly do we plan to get there? And once we do, how will we survive and eventually conquer Mars? These are the questions we'll answer in today's video. Be sure to like and subscribe for more fascinating explorations of space and science. But first, what does conquering Mars even mean? For some, it's as simple as sending an astronaut to plant a flag, much like we did on the Moon. For others, it means building a permanent base with rotating crews, similar to the International Space Station. And for the most ambitious, it means terraforming Mars, transforming its entire environment so that humans can live there without spacesuits. No matter which vision you prefer, even the simplest goal, just landing a human on Mars, is an extreme challenge. If astronauts could travel there and return safely, that alone would be an enormous achievement. But why is this so difficult? After all, humans landed on the Moon multiple times more than half a century ago. Shouldn't we have reached Mars by now? The short answer is, traveling to Mars is not just harder than going to the Moon, it's incomparably harder. Let's take a step back and understand why. The first humans set foot on the Moon on July 20th, 1969. And it wasn't just a symbolic mission. Astronauts worked there. In total, 6 manned missions landed on the lunar surface, and 12 people walked on the Moon. It took just 7 years from President Kennedy's famous 1962 speech to make that dream a reality. That's incredibly fast. So, what's wrong with Mars? Why haven't we been able to send a single person there in all this time? Even Elon Musk, the most optimistic advocate for Mars exploration, has admitted that it will be extremely difficult. In an interview with entrepreneur and space visionary Peter Diamandis, Musk was blunt. Honestly, a bunch of people will probably die in the beginning. That statement alone speaks volumes about the risks involved. But what exactly makes it so difficult? Let's put it in perspective. Imagine you need to walk to a shopping mall about 1 kilometer from your home. It's an easy trip. You could do it in slippers, and it wouldn't take more than 15 minutes. Now, imagine that instead of 1 kilometer, you have to walk 140 kilometers, and then walk back. That's like walking from New York to Philadelphia. Suddenly, the journey isn't so simple, but it gets worse. Imagine that this entire route has no roads, no stores, and no other people. You'd need to carry all your food, water, medical supplies, tools, a tent, and a sleeping bag, because there's nowhere to stop and restock. If you were injured halfway through the journey, you'd likely be doomed. Now multiply that difficulty 100-fold, and you start to understand what traveling to Mars is like compared to traveling to the Moon. The Moon is only 384,000 kilometers from Earth. That's far, but still manageable with current technology. In contrast, Mars is at least 56 million kilometers away at its closest approach, about 140 times farther than the Moon. But that's just the minimum. Depending on where Earth and Mars are in their orbits, they can end up on opposite sides of the Sun, increasing the distance to 400 million kilometers. That's over 1,000 times farther than the distance to the Moon. In our hiking analogy, this is like walking not just from New York to Philadelphia, but from New York to Chicago. And remember, you're still carrying all your supplies with you, because there are no resupply stations along the way. But distance alone isn't the only challenge. In the vastness of space, speed is relative. With modern technology, a one-way trip to Mars will take at least 7 months, possibly close to a year. That's because we can't just take a direct route. Spacecraft must follow a precise trajectory that takes advantage of planetary motion to minimize fuel consumption. Even with the most advanced propulsion systems, interplanetary travel is painstakingly slow compared to the vast distances involved. And the challenges don't stop there. During this long journey, astronauts will have to survive in an extremely confined space. They'll need food, water, air, and medical supplies for the entire trip. They'll have to maintain their physical health by exercising regularly in microgravity, or their muscles and bones will weaken. They'll also need to take care of their mental health. Imagine being locked in a small spacecraft for months with no way out, no fresh air, and only a few other people for company. Communication with Earth will have long delays, up to 20 minutes each way, making real-time conversations impossible. Every decision will have to be made carefully, as there will be no immediate help if something goes wrong. And then comes the biggest challenge of all, landing on Mars. Mars has an extremely thin atmosphere, meaning parachutes alone aren't enough to slow down a spacecraft. Instead, engineers are developing a combination of heat shields, supersonic parachutes, retro-rockets, and inflatable deceleration devices to safely land astronauts. Even with these innovations, landing a spacecraft safely on Mars is still one of the most technically demanding tasks in spaceflight. Once astronauts arrive, they'll face an environment that is extremely hostile to human life. Temperatures can drop to extreme lows, radiation levels are dangerously high, and dust storms can last for months. But perhaps the most important question is this: why go through all this effort? Why do we want to go to Mars at all? Some argue that exploring Mars is humanity's next great adventure, a natural extension of our desire to explore the unknown. Others believe that establishing a presence on Mars is crucial for the survival of our species, an insurance policy in case Earth ever faces a catastrophic disaster. And then there are those who dream of turning Mars into a second Earth, a planet where future generations could thrive. Whatever the motivation, one thing is clear: getting to Mars will be one of the greatest challenges humanity has ever faced. But if history has taught us anything, it's that we are a species driven by curiosity, ambition, and the relentless pursuit of the impossible. So, will we see humans on Mars in our lifetime? And if so, will they be able to survive and build a future there? Only time will tell. But one thing is certain: the journey to Mars has already begun. Imagine being millions of kilometers away from Earth, surrounded by an environment that wants to kill you at every turn. Cosmic radiation, life support failures, and no chance of immediate help from Earth. Even asking for simple advice from mission control could take 10 to 20 minutes just to receive a response. How do we even begin to prepare for a mission like this? Is it even possible to predict its success? Well, let's look at the numbers. In over 60 years, 48 missions have been sent toward Mars. Some were flybys, others sent probes or rovers, and yet out of those, 26 failed. That means that even for unmanned missions, the success rate is barely above 50%. If robotic missions struggle this much, what are the odds of humans surviving the journey? No wonder Elon Musk once said, "Honestly, a bunch of people will probably die in the beginning." Coming from someone known for his relentless optimism, that statement is chilling. But should we let these dangers stop us? Throughout history, humanity has never given up on ambitious dreams just because they were difficult. Instead of focusing on the risks, let's see how the optimists plan to overcome these challenges and make Mars exploration a reality. So, how do we even get there? The first and biggest challenge is escaping Earth's gravity. How much equipment do we need to take? What kind of rocket would be capable of carrying such an enormous payload? To understand the problem, let's take a look at the rockets we've used in the past. The Space Shuttle, which transported astronauts to Earth's orbit, was an impressive machine, standing 56 meters, 183 feet, tall. But even that looks tiny compared to the legendary Saturn V rocket, which sent humans to the Moon. Now imagine what kind of massive rocket would be needed to take humans, supplies, and life support systems all the way to Mars, land safely, and then return to Earth. It's almost impossible to build a single rocket that can do all of that. Let's go back to our earlier analogy. Imagine a hiker needing to travel 140 kilometers, 87 miles, through completely uninhabited terrain, carrying all their supplies in a heavy backpack. Now here's the real challenge. The first kilometer of the journey is up a steep and nearly impossible hill. If they can't climb it, the journey is over before it even begins. This represents the problem of launching a Mars mission directly from Earth. It requires an incredible amount of energy just to break free from gravity. So, what's the solution? NASA has decided that the first human mission to Mars won't start from Earth at all. Instead, they're planning to launch missions from space itself. The idea is simple: transport all the necessary parts, fuel, and cargo into Earth's orbit in multiple launches, then assemble the spacecraft there before heading to Mars. This significantly reduces the energy required to start the journey. But NASA isn't stopping there. They're taking this idea even further by building a base on the Moon and a space station in lunar orbit. Why? Launching from the Moon has a huge advantage. It has much weaker gravity than Earth. This means that missions could be launched with far less energy, making the journey to Mars much more feasible. The plan is to use a lunar station as a supply hub and refueling point before sending astronauts on their interplanetary voyage. But how close are we to making this happen? NASA's Artemis program is already in motion. This ambitious plan consists of multiple phases, each bringing humanity closer to deep space exploration. The first step was Artemis III, an unmanned test mission that launched in November 2022. A powerful new rocket called the Space Launch System, SLS. Designed using technology from the Saturn V and Space Shuttle, sent the Orion spacecraft on a journey around the Moon before safely returning to Earth. This was just a test, but it proved that we're capable of reaching the Moon again. The next step, Artemis II, is scheduled for September 2025. This time, there will be a crew on board. While they won't land on the Moon yet, their 10-day mission will orbit it, ensuring that all systems function correctly in deep space conditions. This mission is crucial because it will confirm that the spacecraft is ready to support human life beyond Earth's orbit. Then comes the real milestone, Artemis III. This mission will send astronauts to land on the Moon for the first time in over 50 years. However, Orion itself isn't designed for lunar landings. Instead, astronauts will transfer to SpaceX's Starship, which will serve as the lunar lander. This mission will mark a turning point in space exploration, setting the stage for long-term human presence on the Moon and, eventually, the journey to Mars. If Artemis is successful, it will lay the foundation for humanity's next giant leap, an interplanetary civilization. But what will it take to make Mars truly habitable? Will we ever terraform it? Can humans thrive on a planet so different from Earth? These are the questions we must answer in the coming decades. What we do know is that we're closer than ever before. The dream of walking on Mars is no longer science fiction. It's a challenge waiting to be conquered. And with the right technology, determination, and vision, we might just make it happen within our lifetime. What does it truly mean to conquer Mars? Is it simply planting a flag like we did on the Moon? Or does it mean building a permanent settlement, making Mars a second home for humanity? Whatever the vision, even getting there remains an enormous challenge. But wait, why is it so hard to reach Mars? We landed on the moon over 50 years ago, so what's stopping us from doing the same with Mars? If Elon Musk's predictions were right, we should be preparing for humans to land on Mars next year. Yet, as of now, that vision seems more distant than ever. So, what went wrong? For starters, let's compare the challenges. Imagine you need to walk 1 kilometer, about 0.6 miles, to a store. It's easy, right? Now imagine you need to walk 140 kilometers, 87 miles, through a desert. No roads, no water, no shelter. That's roughly the difference between going to the moon and going to Mars. The moon is a mere 384,000 kilometers, 238,857 miles, away. Mars, at its closest, is 56 million kilometers, 34.8 million miles away, 140 times farther. And when Earth and Mars are at their farthest distance, that increases to 400 million kilometers, 248.5 million miles. With current technology, a one-way trip to Mars would take at least 7 months. Think about that. 7 months confined in a small spacecraft with limited supplies and no chance of immediate rescue. And even if the crew arrives safely, they'll face extreme radiation, sub-zero temperatures, and an unforgiving environment with no oxygen. So, how do we overcome these obstacles? NASA's approach involves a stepping stone strategy, using the moon as a training ground. Why? Because launching a Mars mission directly from Earth would require an impossibly large rocket. Instead, NASA is building the Lunar Gateway, a space station orbiting the moon that will serve as a refueling and assembly point for deep space missions. The Artemis program is the first step in this plan. Artemis thoroughly successfully launched an uncrewed Orion spacecraft around the moon in 2022. Artemis II, planned for 2025, will take astronauts on a similar journey without landing. Then comes Artemis III, the first human landing on the moon since 1972, using SpaceX's Starship. But why return to the moon at all? Because it's the perfect place to test long-term space survival. What will astronauts do on the moon that will help with Mars? First, they'll practice extracting water from lunar ice. Why is this important? Because water can be split into hydrogen and oxygen, creating fuel for rockets. If we can extract resources from the moon, we can do the same on Mars, reducing the need to carry everything from Earth. The Perseverance rover has already demonstrated a similar process on Mars, extracting oxygen from the planet's carbon dioxide atmosphere. Another critical step is learning to build shelters. How do we protect astronauts from deadly radiation? NASA is exploring 3D printing technology to construct habitats using lunar and Martian soil. They've even partnered with a construction company, ICON, to develop this technology. If successful, astronauts on Mars could print their own shelters instead of hauling heavy materials from Earth. But before we reach Mars, there's still a long road ahead. Future Artemis missions will focus on perfecting these technologies. By Artemis 12, astronauts will likely be conducting advanced research on resource extraction and habitat construction. By Artemis 14, they'll be testing emergency survival scenarios, preparing for the worst-case situations that could occur during a Mars mission. So when will humans finally set foot on Mars? NASA hasn't announced a definitive date, but current estimates suggest sometime in the 2040s. However, private companies like SpaceX are pushing for a much sooner timeline, possibly within the next decade. Who will win the race? Government space agencies or private enterprises? One thing is certain: the journey to Mars is the greatest adventure humanity has ever attempted. And while the challenges are immense, our determination to explore the unknown has never been stronger. So, will we see humans on Mars in our lifetime? And if we do, what will be the next step? Establishing a colony? Terraforming the planet? Or perhaps preparing for an even greater journey, one that takes us beyond our own solar system? Space travel is full of dangers, cosmic radiation, equipment failures, and the inability to get immediate help from Earth. Even the simplest advice from specialists can be delayed by several minutes. Can we predict the likelihood of success for a Mars mission in advance? Let's look at history. Over the years, many missions have been sent to Mars, but nearly half have failed. If unmanned missions struggle, what does this mean for human explorers? Elon Musk has warned that the first Mars explorers will face extreme risks, including possible death. Does that sound terrifying? Absolutely. But despite the risks, humanity is determined to push forward. So how do optimists plan to make this journey possible? Let's find out. The first challenge is escaping Earth's gravity. How do we take everything we need to Mars? Imagine carrying a massive backpack filled with supplies through a difficult hiking trail. Now, imagine the first part of the trail is a steep, nearly impossible climb. That's the challenge of launching a fully loaded spacecraft from Earth to Mars. Instead of launching everything at once, NASA plans to assemble the spacecraft in space, where there's no gravity. But where would this assembly take place? The answer: a base on the Moon and a space station in lunar orbit. Why the Moon? Launching from there would be much easier than from Earth. The plan involves sending supplies in multiple trips, storing them at a lunar station, and then launching the Mars mission from there. This approach makes sense, but how far has NASA gone with this plan? The Artemis program is already in motion. The first phase tested NASA's massive SLS rocket, which sent the Orion spacecraft around the Moon and back. The next phase will send astronauts to orbit the Moon, and eventually they will land, build a base, and conduct research. But what does this have to do with Mars? Everything. The Moon will serve as a training ground, allowing scientists to test long-term space living, resource extraction, and survival techniques. So, what's next? The Gateway space station will be built in lunar orbit, serving as a launching point for future deep space missions. What will astronauts do there? They will conduct experiments, develop infrastructure, and test life support systems. Step by step, these missions will prepare us for the ultimate goal: reaching Mars. Once the Moon base is operational, NASA will turn its attention to Mars. But how do we prepare for such a journey? The key is sustainability. Astronauts will need to generate power, produce oxygen, and recycle waste efficiently. One solution is a compact nuclear reactor, which will provide energy regardless of weather conditions. Wouldn't solar panels be enough? Not necessarily. Mars has frequent dust storms that can block sunlight for months. Nuclear power ensures a steady energy supply. Astronauts will also test plant growth in lunar soil, using microbes to recycle waste into fertilizer. Could this work on Mars? Yes, and NASA has already tested a similar oxygen extraction experiment on the Red Planet. Before humans set foot on Mars, what needs to be done? The first step is sending equipment in advance. Special landers will deliver fuel, supplies, and power systems before astronauts arrive. Why is this necessary? Because once humans land, they'll need immediate access to resources. The second step is sending a Mars ascent vehicle, which will eventually carry astronauts back to orbit. Finally, the crew will travel from the Moon to Mars in a specially designed spacecraft with radiation shielding and life support systems. Once in Mars orbit, how will astronauts land? They'll use a pre-delivered landing module, which will also serve as their first home. Instead of bulky spacesuits, they'll travel around Mars in a pressurized rover. Think of it as a space RV. What's inside? Sleeping quarters, medical facilities, a lab, and even an exercise area. This rover will allow them to explore without the constant need for a suit. But how do they get back? After completing their research, the astronauts will launch from Mars in the ascent vehicle, dock with their spacecraft in orbit, and begin the long journey home. This trip will take months, with only a few key launch windows available. Why is timing so critical? Because planets move, and the right alignment minimizes travel time and fuel use. There are two possible routes for a Mars mission. One option takes longer but uses less fuel, allowing astronauts to stay on Mars for an extended period. The other requires more fuel but reduces the mission length significantly. Which is better? NASA is leaning toward the shorter trip to reduce radiation exposure and equipment failures. Interestingly, the shorter route involves flying past Venus. Why? Because orbital mechanics sometimes work in unexpected ways. Using Venus for a gravity assist helps astronauts reach Mars faster. So, when will humans finally land on Mars? NASA's current goal is within the next 2 decades. However, space missions are complex and delays are inevitable. But every step taken on the Moon brings us closer to Mars. The dream of living on another planet is no longer science fiction. It's a future that humanity is actively working toward.